my screen to you. Oh, I did put in those assessment grades, PS. So just as a heads up, those are in there. I put them in like during my hall duty today. So um I don't think they like overly affected anyone's grades. People in my other class did ask me, will you be able to do um like a requiz? And you will. It's just I'm not, I don't know when. We'll see what life is like after post vacay, and then we can decide if you'd like to do a makeup. But everything's just going to kind of depend on life after vacation. Sorry, I need to like get at a good angle here. Here we go. So today we're going to solve the rational equations. So I'm going to bring you through the steps. I know you saw some kind of basics yesterday. Um, maybe you got something out of it. Maybe you didn't. Who knows? I'm going to get a new pen here. My pens are running out, just like my markers run out. This is like the story of my life here. Okay, so let me write my first equation and then we'll go through how to solve it, what the steps are, all that fun stuff. But here is the problem. Excuse me. Too much talking today. All right, so here's my first problem. I'll always try to give you a minute or two to kind of get caught up. So our main goal is obviously to solve this, but there's a lot going on. We have x or variables in different places. We have fractions. It's a big pain in the butt. So we want to, make it as easier on ourselves as possible. And the way we're going to do that is we're going to find the common denominator of all of these fractions. I write it off to the side. So I'm going to find the common denominator of these fractions. So this has an x minus 3. This is technically just over 1, right? And that's x minus 3. So my common denominator is just x minus 3. Everything's represented with that, so we're good. Once I know what my common denominator is, I'm going to go back and multiply each term by that common denominator. So I'm going to multiply everything times x minus 3. So I kind of just like put it up with a numerator to show that I'm multiplying that. So the reason I do that is now to hopefully simplify some of my fractions. So what is going to happen is the x minus 3 and the x minus 3 are going to cancel, and I'll just be left with 6 plus. Nothing cancels here, right, because that's just over 1. So I can distribute that 9 in, and I'm going to get 9x minus 27. Just don't lose signs, and I have my equals. And here the x minus 3's would cancel, and I'll be left with negative 3. So from here to here, this is looking way better, right? This is looking way more manageable to solve. That's always our main goal, make our life as easy as possible. And we do that once again by multiplying everything by the common denominator. That's going to cancel a lot of your fractions for you. Now let's actually solve it. So if I combine like terms here, I would get 9x minus 21 equals negative 3. If I add 21 to both sides, I would get 9x equals 18. And then when I solve that bad boy, I'm going to get x equals 2. Now, I am not done. So we are used to solving something and being like, good, got an answer, all set, move on. You have to check your answers. It's part of the problem. So we are not done yet. If you stop here, you're going to get some problems around in the future. So just make sure every time you have to check. And that's what an extraneous solution is. It's when you check it and it doesn't work. We call it an extraneous solution. So you have to do that step. In this case, I don't know if it's going to work. So let's check. We check an answer by plugging it back into the original equation for x. So we would have 6 over, instead of x minus 3, I'm going to write 2 minus 3 because we just solved for that x, plus 9 equals negative 3 over 2 minus 3. My main goal when I check, I always kind of do that, is I want to make sure my left side, oh, sorry, I'm in the way over there. I want to make sure the left side is equal to the right side. So that's how I know something is correct. So here, that would be what, 6 over negative 1, right? Yeah, that would be negative 6 plus 9, which is 3. So that's my left. And then over here, that would be negative 3 over negative 1, which is also 3. So since the right equals the left, I'm good. So that is a solution to my equation. So you do need to check. If it works out, you're good. That's a solution. If it doesn't work out, we'll see what happens in a minute. So I will show you what extraneous solutions look like and how to deal with them. So I'm just going to leave that up for a few seconds. I know depending on where you're sitting, it might be hard to keep up. But if nothing else, you write it down because then you just have some more examples to look back at in the future. Just let me know. As we're working, always feel free to interrupt me. You can either like throw your mic on and ask me something, or you can always put something in the chat. I do have my other screen up. But please don't sit there confused. So please ask if you need it. Any questions on one? Okay. So let's go to number 2. Sorry, let me just do this. This thing's wicked annoying, the base of it. Okay. So for number 2, same idea, we're going to start with a rational equation. So we have 2 over x plus 2 minus 1/2 equals negative 3 over 4. So my first step, it's going to be my first step every time, is find the common denominator. And we'll go from there. So the common denominator, remember, everything has to be represented. So I need an x plus 2. And then here, these are just like numbers, constants, right? If I have a 2 and a 4, the least common denominator will be 4. So my common denominator is 4 times x plus 2. So then everything's kind of represented. You can multiply to get to there, all that fun stuff. So once I know this, I'm going to go back and multiply everything by that. So everything's going to get multiplied by 4 times x plus 2 times 4 times x plus 2. I know it's kind of a pain to write it out every time, but it really does keep you a little bit more organized if you do so. So now let's see what happens. Here, the x plus 2's cancel, and I'm left with 2 times 4, which is 8. Okay, that wasn't bad. Here, I can reduce this, right? 4 over 2 will reduce to 2. So I'm going to kind of cancel that, make that into a 2. Just be careful here. I was rushing, as always, and because I had a million things to do, and I was doing this problem quick, and I messed it up. And it all had to do with this sign. So when there's a minus sign, just remember you are distributing it to both terms. I only distribute it to one, and then it messed me up good and bad. So think of this as a minus or a negative 2, and that's what you're distributing. So if I distribute that, I would get negative 2x and minus 4, right? Yeah. And then equals on this side, the 4's would cancel. And remember, this is a negative 3, so I can distribute that in, and I would get negative 3x minus 6. All right, let's actually solve it now. So let's combine like terms over here. I'll get negative 2x plus 4 equals negative 3x plus 6, excuse me, minus 6. I keep just changing signs for some reason. I don't know what my problem is today. Let's get our x's on the same side. And then let's actually solve. So let's isolate that x, and I end up with x equals negative 10. Okay. Remember, I'm never done at this point. I know we want to be done because that's like what we feel comfortable with. You have to check your answer. So off to the side, I do a quick little check ski. I'm going to fill in, or you can use a calculator, or you can do it in your head. You just need to check it. So I'm going to throw that negative 10 in for x. So 2 over negative 10 plus 2 minus 1/2 equals negative 3/4. I'm trying to make sure that the left side equals the right side. I'm just grabbing my calc because it's easier. So that would give me what? 2 over negative 10 plus 2 is 8, negative 8. So 2 over negative 8 minus 1/2. So I have no clue what it is. I'm just throwing in my calculator. It comes out to negative 3/4. And I'm feeling good about life because the other side was negative 3/4. Those are equal. So this is definitely an answer. So like back in the day when you solved equations, you could check them if you really wanted to like be overly cautious, but now you have to check them. And we'll talk in a minute about what it looks like when something is extraneous, but those do pop up. Okay, I'll give you a few seconds to write anything down. Oh my goodness. It's really boring in school when no one is here. I literally have no one to talk to all day. Minus little dots on my screen, guys. I need to like get up and do some jumping jacks after this. Any questions? Oh yeah, what's up?
I have a flu shot appointment at 2. Is it okay if I?
Yeah, who's talking right now?
Megan.
Megan. Okay, Megan. Yeah, if you have to sign off early, go for it.
Do I need to do anything?
No, I'm just gonna take attendance at the end, so you're all set.
Thank you.
Thanks. All right, let's look at number 3. Hey. What do we got? 10 over x times x minus 2 plus 4 over x equals 5 over x minus 2. Okay, so that's my prob. And we are going to find the common denominator first. I'm getting lazy, so I'm just writing CD over here because I don't want to feel like writing the whole thing. So I know I need an x in the common denominator, right? There's one there and there's one there. I know I need an x minus 2. And now that I have that written, I see everything is represented. So my common denominator is x times x minus 2. So I'm going to go back and kind of multiply each term times that. I kind of just line it up next to the numerator. And let's see what's going to happen. So this, the whole denominator will cancel, and I'll just be left with 10. Plus, here the x will cancel. Sorry, it's kind of hard to cancel an x. I do have that 4, and I can distribute it into that binomial, and that will give me 4x minus 8. And then just don't lose signs, equals. The x minus 2's cancel, and I'll just be left with 5x. Okay, so nothing too crazy. I'm just kind of going through the motions here. 4x plus 2 equals 5x. And if I get my x's on the same side, then x is going to equal 2. All right. So we're going through, we're doing that fine. We found an answer, but we're not done because we always need to check our answer. So when I go to plug it back in, I have 10 over 2 times 2 minus 2 plus 4 over 2 equals 5 over 2 minus 2. And I'm getting a little worried because I have a 0 in the denominator, which is bad news. A 0 in the denominator, bad news. Remember how we wrote those restrictions before? Like, that's kind of what we're saying. Like, this is a restricted answer because when I plug it back in, it gives me a 0 in the denominator. So when I checked it, since it's like, it's a big hot mess, and we never want zeros in the denominator, we would say this is an extraneous solution. So once again, I noticed it one, if you had gone back and actually just written your restrictions, it would have been one of them. Or if you just plug it in, you notice there's 0 in denominators. That means that this is extraneous. We solved for it. It looked like it was going to work, but when you plug it in, it doesn't. So it's not an actual answer. We call it an extraneous solution. There's nothing else, right? There was no other answer to this. So since the only answer that we had was extraneous, we would say that the answer to this is no solution. So there's nothing else that I could plug in to make that equation true because the one thing that we found didn't work. So we would say this is a no solution problem. So once again, extraneous just means when you plug it back in, if it doesn't work or if the two sides aren't equal to each other or something's wrong, it means your answer is extraneous. And if you think about going back to talking about restrictions, which we were doing, basically that goes against our restrictions, that x cannot equal 2 or 0. So just as a heads up for number 3. Once again, you were kind of just going through and it seemed like it worked. So you were, there was no red flags. So you do have to go back and always check your answers. Once again, I always like to give you a few seconds just to get caught up if you need it. We got 3 more. They shouldn't be too torturous here. Oh my goodness gracious here. All right, so let's do number 4, and then we'll wrap up with 5, 6, and then we'll be good. Boop. So we have x minus 3 over x squared minus 25 plus 1 over x plus 5 equals 1 over x minus 5. I'm just going to move this a little. Sorry, I know my arm is in the way. It's just this space gets in my way and I get mad. Okay. So we have a nice little equation. Just like with adding and subtracting, when we find any common denominator, we do need to make sure our denominators are factored. So in this case, sorry, the hiccups. In this case, I would factor this first denominator. It is a difference of 2 squares. So I always kind of rewrite it at this point. Okay, now I can find my common denominator. So off to the side, my common denominator in this case would be x plus 5, x minus 5. Everything's rect, so we're good. Sorry, I messed up my leg here. So now we can multiply everything by the common denominator. So I'm multiplying everything times x plus 5, x minus 5. Oh, sorry. All right, sorry, takes a minute to set that bad boy up. So then we'll just see what happens. In this case, that whole denominator would cancel. I would be left with x minus 3. Here, the x plus 5s would cancel. I'm just distributing a 1 in, so I would be left with plus x minus 5, or plus 1x minus 5. Keep my equals. And here, the x minus 5s cancel. So once again, if I distribute a 1, I'll just be left with x plus 5. Not too shabby. So let's do a quick little solve ski here. What's that? 2x minus 8 equals x plus 5. Get your x's on the same side. And then just solve. And x is going to equal 13. Sorry. I got new pens now. I'm never done. I have to check my answer. You could use a calculator, you could use your brain, you could use whatever you please. Just make sure that the left side equals the right side. So that gives me 13 minus 3 over 13 squared minus 25. I'm going to use my calculator to do most of this. Over 1 over 13 plus 5 equals 1 over 13 minus 5. Okay, so I'm going to focus on that left side. I grab my calc. I know that 13 minus 3 is 10 over 13 squared minus 25. Does that come out to 144? Yeah, it comes out to 144. So I end up with 10 over 144 plus 1 over 18. Okay, I mean, these are kind of weird numbers, but I'm just going with it. I just look it up in my calculator. It comes out to 1/8. So I have the calculator do all the tough stuff for me. And on the other side, that side's pretty easily because that's just 1/8. Ooh, yay. Right equals left. I'm good. So that is definitely a solution to my problem. Here's a piece of paper. So same steps, right? Common denominator, multiply everything by it, reduce your fractions, solve your equation, check your answer. So that's always your main goal. All right, 2 more. Bear with me. I never know if our class actually ends at 2 or 2:10, but we should be done before then. Who knows? This is such a weird year. All right, number 5. So we have 3x over x squared minus 4 minus 2 over x plus 2 equals 1 over x plus 2. Excuse-moi. So we are going to factor the denominator first. All right, this is a difference of 2 squares. And then the other ones stay the same. The common denominator would be x plus 2, x minus 2. And then everything's represented. You're good. So everything's going to get multiplied by that. So I'm going to multiply this by x plus 2, x minus 2, and so on, and so forth. Okay. That's good. I don't know how you guys sit all day. God, I'm dead. All right. Cancel, 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 cancel. I'm left with a 3x. The x plus 2's cancel. And then once again, just be careful because that's a minus or a negative 2 that you're distributing now. So that will give you minus 2x plus 4 equal sign. The x plus 2's cancel. I'm just distributing a 1, so I'll be left with x minus 2. Okie dokers. Let's combine like terms here. What do we get? X plus 4 equals x minus 2. Now, when we try to get our x's on the same side, they cancel. I have no x's left. The thing I'm left with is 4 equals negative 2, which we know is not a true statement. You've seen the situation before when you're just solving equations with variables on both sides. It pops up, and it pops up here. What this means is no x's, untrue statement. This is a no solution problem. There is nothing that I can plug in for x that would make that equation true. Magical. So I just wanted you to see sometimes it's no solution because you have extraneous. Sometimes it's just no solution because it doesn't make sense. So in that case, your variables canceled. Your statements were untrue. Ugh. Therefore, it is a no solution. Sorry, I'm going to try to give you a few seconds so we can get caught up. Now the last one, which we're about to do, we're going to set it up, same setup, common denominator, multiply, see what you got. We are going to have to solve a quadratic. Ooh, how exciting. You guys did quadratics last year in whatever the heck that class is called, Algebra 1 geometry. This is geometry algebra 2. So you did them. We are actually going to do more with quadratics as we go forward. That's actually what we're going to be doing as we come back from vacation. Quadratics is one of those things that always pops up. No matter what the math class you take, you'll see it pretty much. We'll focus more. If you don't remember quadratic formula or you're just like a little rusty, we'll do that after vacation. For now, we'll just focus on like solving with factoring. So nothing crazy. I know you guys know how to factor at this point because we've been factoring our little brains out all year. But just as a heads up, there will be some quadratics. We're going to focus on factoring to solve. So here's our last problem of the day, really last problem of the year, right? 2020. I'll see you tomorrow, but we're just like doing a game. So let's start next year fresh, happy, healthy. Even though I might go crazy over vacation. I was like going nuts this weekend because there's just nothing to do, but I guess it's better than waking up at the crack of dawn and coming here, but still, I like to see people. I miss people, guys. Okie doke. Last one. First thing I need to do is I look and I say, well, I can't find the common denominator until the denominators are factored, so I'm going to start with that. So I'm going to factor that last denominator. What will I get? X plus 5, x minus 4. All right. We need to find the common denominator, and in this case, it would just be x plus 5, x minus 4, because with that, everything is represented. Or if you wrote x minus 4, x plus 5, same deal, as long as you had those two binomials. So now I'm going to go back and multiply every single term by that common denominator. So x plus 5, x minus 4, so on. Ooh, sorry about that. And so forth. All right, so now we're at least set up and we can kind of see what's reducing, what we're left with, all that fun stuff. The x minus 4's cancel. And I have x times x plus 5, so I would distribute into that. That would give me x squared plus 5x. All right, just be careful. This is a minus over here, so I'll never forget that. But the x plus 5's cancel. And then I'm distributing, think of that as negative 4. I'm going to distribute. That would give me minus 4x plus 16. Equal sign. Cancel, 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 cancel. 36. Okay, so we get down to here. It is going to be a quadratic. So we're left with x squared. This would give me what? Plus 1x plus 16 equals 36. So we said what kind of focus if it's a quadratic, I'm gonna make it factorable. I'm gonna try to make it factorable. In order to solve by factoring, you do need to set it equal to 0. So we're going to move this 36 over here, and I'll be left with x squared plus 1x minus 20 equals 0. And now I'll factor it. X plus 5, x minus 4 equals 0. And if you set these equal to 0, we've done this a million times because this is how we did our restrictions. X will equal -5 or +4. So we end up with 2 answers. I'm just giving you a second in case you're catching up. But we're never done. We're never done until we check our answers. So remember, when we check and we plug in, we want the left side to equal the right side. We don't want there to be any restrictions. We don't want there to be zeros and denominators. So that's what we're looking out for when we're seeing if things work or not. Now, I'm going to do this right in my head because you're going to hopefully see. If I try to plug -5 into the original, when I throw it here, it's going to give me a 0 denominator. So this one's out. And we could have even looked at this and listed our restrictions before we started and then check those. But this is extraneous. We have another answer. Sometimes it will work, sometimes it won't. It just depends on the problem. But if I think about plugging 4 back in, if I plug a 4 right here, 4 minus 4 is 0. That goes against what we need. Also extraneous. And once again, since both of our answers were extraneous, aka they don't work, this would be no solution answer. They're not always no solution. It's just the random ones that I picked were. Sometimes you might have 2 answers and one works and one doesn't. It really just depends on the problem. So I don't want you to think it's always no solution when you see extraneous. It just depends if part of it works or not. And in that case, neither of them did. So take a moment. If nothing else, you write it down. So now when we come back from vacation, I am so sorry, but oh my God, I need to get up. When we come back from vacation, we've at least, seen a few more examples. Hopefully, if you had any questions from yesterday, you've cleared them up. If not, I can always answer them because that is my job, guys. So please always ask if you're confused. I think some people in my other class had said, like, some of the work you were doing yesterday, there were a lot of fractions. I have to go back. So this is the bad thing about life is like we're planners and we plan, like I made that lesson like 3 weeks ago and now I need to go back and find all the answers. So it might take me a little bit, but I will go back and find that and we can go over anything after vacation as well. But once again, being a planner, it's hard. It's hard in these unknowing times because we're just a mess. So once again, when we come back from vacation, we will be staying together as kind of one group. So if we have a group in front of us, then the people at home are you guys are going to be kind of chugging along with us. So just as a heads up. So if you've been a person that's been like taking naps during our class and then doing your work later, that's not going to work after vacay. So just as a heads up. And it's not a forever thing. It's just like until things die down thing. Hopefully it's sooner rather than later. But then tomorrow I will see you just for like a quick little game. I think that's the main stuff. Sorry, I'm just Xing out of this. Boop. I'm going to stop presenting. Sorry, as I'm like laying